Hi kids. Alright, we're going to do a vector Coulomb's law problem here. I have 3-point charges, a 10 microcoulomb charge, a negative 5 microcoulomb charge, and a negative 7 microcoulomb charge. These two are separated by 6 meters, these two are separated by 5 meters. Okay? And I want to find the force, the net force that's going to be exerted on this charge right here. So, anytime I ask you to find force, first thing we should always do is we should draw our free body diagram. So let's draw a free body diagram. So here is my positive 10 microcoulomb charge, okay? And if I do the forces acting on it, so these two forces, or these two charges are oppositely charged, so they are going to attract. That means the force acting on this one is going to point to the right. So the force acting on this one is going to point to the right. So I'm going to have a force on it this way, and I'm going to call that the force on 1 from 2. So this is the force on charge 1 from charge 2. Make sense? Okay, so if I look at these two, okay, these two charges, the 10 microcoulomb charge and the negative 7 microcoulomb charge, they are oppositely charged, so they will also attract. That means the charge acting on this one is also going to be to the right. So I'm going to have another force going this way, and this would be the force on 1 from 3. Okay, so I have two different forces acting that way. So that hopefully my free body diagram makes sense. So after I find how big each one of these forces are, then, excuse me, thank you. After I find how big each one of those forces are, then because they're pointing the same direction, we're going to have to add them together to get your net force. If they're pointing opposite ways, then you would have to subtract them to get your net force, bigger minus smaller. If they were pointing like this and this, you would have to add them together as vectors, okay? But doing this problem, they're both pointing the same way, so I need to figure out how big each force is. So if I say the force, well, we know the formula is KQQ over D squared. So if I do force on 1 from 2, that's going to be K, which is 9 times 10 to the 9th. Times Q1, which is 10 times 10 to the minus 6. Remember microcoulombs, minus 6. Times Q2, which is negative 5 times 10 to the minus 6, divided by the distance squared, which is 12, or 6 squared. So force on 1 from 2 equals, let's do some math, 99 times 10. 6 times 6 divided by 36. Okay, and when I do the math, I end up with a negative 0.0125 newtons. Now, the negative tells you that they attract, okay? But I am not going to worry about the negative because, like I said, the negative just tells you the direction. It tells you that they attract. Instead of putting the negative there, I'm going to get rid of that and just say, oh, this is pointing that way because I got that from my free body diagram. Okay? If I do my other one, and I'm going to use a different color just to make it a little bit easier to see, if I do the force on 1 from 3, it's going to be 9 times 10 to the 9th times 10 times 10 to the minus 6 times negative 7 times 10 to the minus 6 divided by, here's where you got to be careful with your distance. The distance that it is away is actually 11, so it'd be 11 squared. So if we do the math, so 9 times 10 to the 9th times 10 to the minus 6 times 7 to the 10 to the minus 6 divided by 11 squared, and I get 0.0052. Okay, again, I got a negative there, but the negative just tells you which way it's going, so I'm not going to worry about the negative. I'm going to worry about the direction, so I got this. So then to find my net force, I'm going to have to add this plus this to get my net force, and my net force would be F net on charge 1 is going to be, oops, let's put that so we can actually see it. F net on 1 equals 0.0125 newtons plus 0.0052 newtons, and that is going to equal 0.0177 newtons, pointing to the right because it's pointing to the right. So slam, bam, boom, there is your final answer, which you can see right there. Okay? All right, bye kids.